Alright guys, welcome to our today's tutorial. Let's try to look at this question. Okay, so we have this data that we have been given, which is on mass spectrum, infrared spectrum, as well as NMR spectrum, which is nuclear magnetic resonance. Alright, so the first thing that we need to look at here, we need to start with infrared spectrum. Then we come to NMR. Then the last part is mass, which will confirm our molecular weight of the compound. So here they're saying the UV spectrum of this compound shows no maximum above 205 nanometer. So here the spectrum is obtained on a neat liquid sample. Alright, so this is these are the spectrum that we have. Let's try to go through one by one. We'll start with infrared spectrum. So look at this infrared spectrum. You know that infrared spectrum is the one that we use only for functional group. We need just to confirm and identify the functional group. Alright, so looking at this, when you check nicely here, you'll find that in between 2800 and 3200, you'll find this peak here. So this, you should know that near 3000 per centimeters, which is the frequency at which these absorb this functional group absorb or vibrate. So this one, when they say or when you look at it, you find that this is near 3000 per centimeter, and that is CH stretch. So here I can just write on my data. I'll start with okay, I'll start with this IR spectra. So I'm going to write like the first one is near 3000 per centimeter. What is my functional group is CH stretch. So this one which we have, okay, so look at the NMR, which is here. Is there any mount plate? You can't find any mount plate here. So here, this CH which we have, it is not the aromatic ring. Alright, so we go to the next one. Okay, so let me just zoom it. Okay, good. Let's go to this one. Okay, first, before that, let me just go to this, which is here. Here in between 1600 to 1800, there is a peak here, and this peak normally you find that it is near 1700 or 1730 or 1720, somewhere there. So this can be the carbonyl group. So I'll confirm everything that I'm doing. So here I'm going to write so here I can write near so here I'm just going to write near 3, or sorry, not 3, which is 1720 per centimeter, like that. Okay, so this one can be my carbonyl, like that, you see. So then I can come to this structure here, which is here. So this one is in between 2400 to 2000. So in between here it can be 2200 2200 or 2250, and you can see this is a sharp peak. So I'm going to see my my infrared manual. So let me just see my infrared manual. So this is my infrared spectroscopy manual that I have. So let me see the one that I have, which is 2200 somewhere, or 2250. So here I'll be checking from the start, going here alkynes, then here aromatic ring, then alcohol, ethers. So aldehyde, when I come down there, I can't find it. Where is it? All right, so okay, so when I find this one, you can see here there is near 2200. So this is near 2250, which is a nitrile. and it has got a sharp peak. They have even included here a sharp peak. So here I can say this is a nitrile. So I can go to my data which I'm writing now. So this one which is near, or I can just say at 2250 per centimeter, I've found that this is a sharp peak. So I can write a sharp peak, and what is my functional group that I found is a nitrile. So this one is a nitrile, like that, you get. So then I can come to this again. You know that from 1500 going this other direction, you find that this is a fingerprint. But when you see a sharp peak, or yeah, a sharp peak, you can see here, which is from in between 2200, here is just similar to this, which is here for carbonyl. So this one, we are going to use this one, which is in between 1200 to 1400, this one. So this, I don't know, it can be, we need to check on our manual. So in between, so here I'm going to write something like so remember we have this and this. So in between 200 and or 1200 to 1400 per centimeter. So this one, I'm going to check on the manual. Let me check on the manual. Right, so this is my manual. So in between 1200 to 1400. So let me try to find, you can see something like this here on the ether. So there's something which is 1300 to 1000, which is 1300 to 1000. So here you can see that this is a CO, which is an ether, and here you can check, and here on the ether there is a CO stretch, which is 1300 to 1000, and here there is 7.7 to 10. You can check on your data there. So this is the same, the peak that we're talking about here, from here saying 13 to 10 to 1000, and this is the peak that we are looking for. So here we can say that we have something like okay, we have something like C, or like that. So these are the function group that I'm having right now, but everything will confirm about that. So here sometimes you can just say because they just say in between this, or there, like it is like 10 to 13,000, like that, like this, 1000 to 13,000 per centimeter. So this is a CO stretch, like that. Then here is a nitrile, this one is a carbonyl, and this one is CH stretch. So these are the functional group that we're having right now. So let me try to go on NMR. So this now will help me to connect on the NMR, and when it comes to mass, and we're going to confirm that. All right, let's try to look at this, which is NMR. NMR, you can see that these are the peaks that are here, and these peaks, so they are on the chemical shift, which are being presented by BPM, you see. So now, these signal peaks here, the one that we said earlier to say they are being determined by n+1 rule, yeah, that is that. So integral in this case, it is defined as the number of hydrogen. So here what we are going to do, so when we say integral here, we're going to say CH3, you get? Yeah. So this, which is what is this? Is it a triplet, or multiplet, or doublet, or maybe you can say singlet? This is a triplet. So a triplet, you know that it is connected. This, which has got 3 hydrogen. So I'm just going to say 3 hydrogen here, which is connected to the one that has how many hydrogen? 2 hydrogen, because n+1, we say n means the number of hydrogen on the adjacent atom. So we say 2 plus 1, I'm going to have a triplet. So let me just write there. So here I'm going to say triplet, which is 3h. You know, we said the integral there, connected to what? So here I'm going to say connected to ch2, like that. Then you are good to go. You are good to go. Let's go to the next one now. So I'm going to come on this. Okay, let me just change the color. Okay, I'm going to come on this one, which is you can see this one is a singlet, but it has got how many number of hydrogen? There are 2 number of hydrogen. So what am I going to do? I'm going to say, so here it means that it has got 2 number of hydrogen. This one has got 3 number of hydrogen. Then here 2 number of hydrogen, like that. So this one has got 2 number of hydrogen. Since it's singlet, it's connected to the one that doesn't have the number of hydrogen. You see, because we use n plus 1 to give us singlet, which is 1. So we are going to say n, which is 0 plus 1, we have 1, like that. So here we're going to say 2h is connected to the one that doesn't have the number of hydrogen. Let's try it. So here we're going to say that is a singlet which has got 2h connected to. So here it is connected to. So which one doesn't have the number of hydrogen? So here we are going to say it is connected to. So the one that will guide us more on this, how they are connected and everything, we'll see on the mass spectroscopy. So here this one is connected to C, which is the carbonyl, the one that we have there as the functional group, and also is connected to the one that is a nitrile, which is like this. Yeah, like this. Good. So okay, like this. Hey, sorry. Okay, good, like that. So let's try to go on the next one, the last one. Okay, this is the one which is a quartet, because it has got how many peaks? 4 peaks. So this is a quartet which has how many number of hydrogen? 2, because of the integral. So we say 2 number of hydrogen connected to CH3. You get, right? So because of the quartet, it is connected to CH3. Why? Because we say n plus 1 is equal to, what is the quartet? Is 4. So we say n supposed to be 3 plus 1, which is 4. So here it is connected to the one which has got the number of hydrogen. How many? 3 of them. So let's write. So here I'm going to say this is a quartet which has got 2 number of hydrogen connected to which is connected to CH3. You see, why are we saying it is connected to and? Because you know that carbon has got the number of bonds. Let me just say it has got 5 provision of or 5 bonds. Why to be stable needs to be connected to 4 bonds, not 5, sorry, connected to 4 bonds. And here it has already have 2 number of hydrogen. We say here 2 number of hydrogen. Then when it is connected to CH3, then what of this bond? Where is it going to be connected? So even here we did the same. So what are we going to do? Remember, on our IR spectra we have this one is our functional group, this one is our functional group, and this one is our functional group. But what we want is for it not to change the term quartet. This quartet means it is connected to only the one that has 4 number of hydrogen. We consider this quartet when we are dealing with the number of hydrogen on the adjacent atom. So here, when I say 2H is connected to CH3, still it is going to be quartet when it is connected to O and O. Because on CO layer, you remember, CO layer, there is this one which is O layer, you get? So this O is where this CH2 has connected to. Even here on the singlet, we don't change this term singlet because 2H is connected to this one, which is the carbonyl group. It will remain the singlet, which doesn't have the number of hydrogen. Even the nitrile doesn't have the number of hydrogen, so it will remain a singlet. So when you reach at that, then you are good to go. You can even connect, but we need also to look at the mass spectroscopy. Let's try to look at that. So this is the mass spectrum. Mass spectrum is just a technique that is used to, or that separates the particles such as atoms, molecules, by using the differences in ratio by their charges. So now, here we are going to say, here mostly we want to know the mass of the compound, mass of the compound. So I'm going to that which is the one that I've been given. So this one which is up there, this is my mass spectrum. So look at this one here, which is mass here. That is but that is the mass of the whole compound that we are going to have. So we can confirm when we write the structure, then we confirm about the compound, the mass of the compound. If we find that this is correct, then we can say we are good to go. So this is my mass over the compound. So I'm going to write, so mass of the compound is 113. So now let me try to find the fragment lost. So on our mass spectrum, I'm going to say, for me to find the fragment lost, I'm going to say 113 minus 86 here. So when I say 113 minus 86, I'm going to have 27. So when I find that this is 27 that I'm having, I'm going on the mass spectroscopy manual, the one that I'm having. Then I'm going to check the one that I have, or the one that I have found, like my data, as well as the one that is there to correspond. So here, this is 27. When you say 113 minus 86 is 27. Let me go on the mass spectroscopy manual. So this is my mass spectroscopy. So I'm going on 27. So here, where is 27? Okay, so this is 27 here. So 27 is C2H5. Yeah, C2H5, somewhere there. Okay. So now the one that which is here, I'm going to get it. Let me get it. Okay. So when I get that one, I'm going to find that fragment lost 113 minus 86, it has given me 27. And when I checked there, it was the C2H5, like that one, which is the same. You can write it as CH2, CH3, because here 2 carbons and 5 hydrogen. So this is the fragment lost that we are having right now. So now let me go to the next one. Let me see what I'm having. Again, here I'm going to say fragment lost. Okay. So if I want, I can just do 113 minus 66 here, so that I see the molecule or the particle which is here. So I'm just going to say 113 minus this one, which is 68. So when I say 113 minus 68, I'm going to have the number which is 45. So when I'm having 45, that 45, I'm going to check on my mass spectrum, which is my mass spectroscopy manual. Let me try to check. So on 35, on 45 here, so where is it? 45. Okay, this is 45. I can even find this one, you see, which is the CH2 or CH3 here, which can also be written as the CH3, CH2, then O. So this is the one that I have found here. So I'm going to get the same and write, so which is CH3, CH2, like this one. So there I can say what I've just done, which is 113 minus 68. So 113 minus 68, I found that this is 45. And 45, when I checked, it was this, which is, okay, let me just write it in this way. Okay, so OCH2, CH3, like that one. So this is the one that I'm having. So I'm just going to connect this. So this one here is just the same. I've just added the one which is on the 68 here. So 113 minus that one. This one was just from 113 to 86, which is this. But I've added this one to find where this one is connected to. So we found that it's connected to oxygen, which is there. So here I'm going to also find the fragment lost. So here I can say, okay, you see, so here I'm just going to say 68 minus 40. So when I say 68 minus 40, I'm going to have 28. So here I found that this is 28. So you do 68 minus 40 is 28. So you go there and check again. 28 on the mass spectroscopy, your manual. Let's try to check. Okay, so I can come here, this is 28, then you find that here the one that we're having, okay, but on your data you find that you have a carbonyl. So this one can work as the carbonyl, which is CO there. It applies that, you can even use it. So I'm going to say here, it means that I'm having a carbonyl, you get? Yeah, that one I'm having a carbonyl. When you do 68 minus 40, that is 28. All right, so I'm going to write it. So fragment lost, 68 minus 40, this is 28, which is carbonyl group. All right, so here I can even, let me just do this. Okay, you can come on the question and you see that this one, which is 40, when you do 40 minus the 29 or 29 minus the 27, you find that these numbers are not, you're not going to find them on the mass spectroscopy. So even 40, when you get 40 there, you find that you check on the mass spectroscopy, which is 40. Let's try, okay, this is that which is air. It's not the nitrile which we have in this one, you get? So I'm going to say, starting from 40, we are having the uncharged fragments. So I can write to say uncharged fragment at 40. So here I'm going to say the one that I'm having is this one connected to, okay, so which is C connected to N, like that one. This is the nitrile, and also this one. Okay, so now let me just look at the data that I'm having, then I come up with the structure, the data that I'm having, then I come up with what? The structure. So okay, so let me check here. Okay, so looking at this, which is IR spectrum, I have these are my function group, which is this nitrile. I have also the CH, the carbonyl, and the CO stretch. Then I come here, you find that this is singlet, which is 2H connected to this and that. So when you look at so here it says singlet, which is 2H connected to carbonyl and also nitrile. Then this one 2H again connected to CH3 and that. So let's come to this, which is mass spectrum. See this one, and let's try to connect with this, which is the CH2 connected, which is 2H, CH2 connected to CH3 and O, and this one which I've just circled here, which is CH2 is connected to CH3 and O there. You see? So this one I can say I can even write it to say O, then CH, okay, 2, then CH3, like that one. You see? Then connected to, so now here I'll come to this one, which is fragment lost, which was here, is this, you get, which is the CO, which is a carbonyl. Because here, remember I said this one, yes, you can get it. Then you come to O. I've just said 113 minus 68. From it was 113 minus the 86, which is this one, but I've extended it to say, okay, let me see where is this is being connected to. 113 minus 68, then I found that this is O CH2 CH3. Then the next one is this one, which is from 68 to 40 28, and I found that this is carbonyl. So I'm going to say this one is connected to carbonyl, like that, you get. Then looking at the NMR data, I've said that this one is connected to that, then we're done. Then we said CH2, which is here, remember CH2, okay, CH2, this one which is triplet here is the one that we have just written to say CH3 connected to CH2, that one is there already, is this one CH, so here is 3, sorry. Okay, so let me write it well. Okay, so it's 3 like this. Okay, CH3 connected to CH2, that is that data. Then even here we had this to say CH2 is connected to CH3, yes, and also connected to O. So this is the data, even the one that we are having here is here that we have written. Then looking at this, which is on the NMR, we found out that here, which is 2H, which is CH2 connected to carbonyl group, and also this one, which is the one that is nitrile. So let's try to connect this one. Then I'm going to say this one here, there is C. Okay, so here it is CH2. Then here is connected to nitrile. Then let me just write the nitrile, which is this one here. You see this one. So even here you can even get it from here. You've seen, right? Yeah, so you can even get it from here. So how are we going to do? We say CH, this one is being connected to nitrile, which is the C. Then here you're going to say N, like that. You get? So now this is the question that they wanted us, or the answer that they wanted us to come up with from the data that we have written. So I'm sure it was 10 marks. For us to come up with the 10 marks, we need to use this IR spectrum, then NMR spectrum, and also the mass spectroscopy, which is mass spectrum. Then we'll come up with this beautiful diagram, or the beautiful structure. All right, so for us to confirm that this is the correct diagram that we are having right now, we need to count or to find the mass. So the mass that we are going to have, the one that we are supposed to have, is this one. This, which is 113, that is the total mass. Remember here we have written that to say on the mass. So this is the mass of the compound. So let's try to count. If you have a calculator near, just get it, then you count the mass of it. Yeah, so I'm going to say how many carbons do I have? 1, 2, 3, 4, 5. So I'm going to say 12. You know that carbon has the mass number, which is 12 times 5. I'm having 60 right now. So I'm going to say how many oxygen do I have? 2, which is plus 32, because 16 times 2 is 32. So plus 32. So I'm having 92 right now. So I'm going to say plus nitrogen. You know nitrogen is 14. So I'm going to say plus 14. Then I'm having 106. That's the one that I'm having right now. Then so here I said okay, so I'm having 106. Then I'll also count the number of hydrogen. The mass number of hydrogen is 1. So I'm going to say how many hydrogen do I have? Which is here I'm having this 2, 5, then here 2, so which means this one is 7. So I have 7. 7 plus 106. 106. Okay. 7 plus 106 is 113. So here I'm going to say is 113. Sorry, not 113. 113. So the mass that I'm having is 113. So here I can prove that what I've done is the correct thing. You see? So we say how many number of carbons? There are 12. 12 times 4. 12 times 5. You're going to have 60. Then number of oxygen is 16. So 16 is 2. 2 times 16. You're going to have 32. Then nitrogen is 14. What about the number of hydrogen? Just 7, which is 1 times 7. So when you count this, you're going to have 113. So this is the mass of the compound. Thank you so much, guys, for watching this video. Please subscribe. Yeah, we are helping one another. Please subscribe.